Hello guys, welcome to this video. In today's video, we are going to be looking at functions. We are advancing slowly to more interesting and more nice stuff. Walking away from the, so to say, boring stuff, the basic things that we are looking at. I know for some people who are coming from languages like C++ and Java, they are kind of feeling bored probably. But if you're a beginner, I hope that you're finding your journey onto interesting and nice stuff as we are moving on. So today, we want to look at functions. What are functions? So I hope you are into the folder where you want to write your Rust code today. And for me, I've already opened my terminal. I'm here, and I want to create my programs in this function folder. So open this folder by writing code space dot, and okay, it has opened. I was waiting for my VS Code. Here it is. Yes, I trust the author. So what we want to do today is to look at functions. I hope this video is going to be very short because I really want it to be very short. So I'll call my file rust.rs, create a Rust file in the functions folder. Okay. So, what are functions? If you're coming from mathematics, that's not what we want to look at today. Function takes an input, and ideally, that's supposed to be how a function should be behaving even in programming languages. But sometimes that's not the case. So, a function, like in mathematics, yes, it takes an argument or a parameter, and then it does something. In mathematics, it is supposed to return something, but that's not always true in programming, and that depends on the type of programming language. For functional programming languages, if you heard about them, that's always true. A function must return something. That means in functional programming languages, there's nothing like a void. Nothing. So, but in Rust, we do not explicitly have void functions, but we kind of have them, as we will see as we advance. So we know that functions, the main core of functions, they mainly help us abstract instructions into named entities. Like we have certain or a set of instructions, and we want to abstract these instructions. We want to combine them into their related entities. We want to combine these related codes together, but also we want to kind of hide some details or kind of put a mask on certain sort of implementations, and we don't want to scatter things around. So that's not the really nice definition of abstraction, but I don't want to be highly technical at this level. So what we need to know that functions abstract a bunch of instructions mainly, and after we have abstracted those instructions, we have put them together in a function. We can always invoke that function, or we can call it and execute it. So guess what? We've already seen functions, and probably some of you didn't know, but we've used the functions. So in Rust, to declare a function, you use the fn keyword or the fn macro from the language itself. So we have the main function always, which is the gateway or the entry point for our programs. So this is already a function. But now today we want to write a function that is not the main entry function of Rust. For example, we want to write an addition function. You guessed it. So this addition function, we want to add two numbers. And this is A, which is unsigned int 64. Yes, integer bit 64. And an argument 2 or two numbers that we want to add, also unsigned int 64. And functions, like I said, when you put something, you expect something. So in Rust, if we want to return something, that means explicitly we want a return from the execution. We are going to put this arrow to point to the return type that we expect. So because the two arguments are unsigned integers 64, and whatever we want to do, we want to add them. So we expect that even the sum should be a U64. Okay, so what do we do if we want to add? We just add those two numbers. Okay, so we've written our first function up away from the main function, and if we want to add those two numbers, what do? We want to declare variables here. Sorry, can't get my L on the keyboard. Okay, got it. Let A, which is unsigned int 64, which will equal to 17, let's say. Then let B, also a U64, equal to 3. Okay, so we can always put a variable onto the result or the return of a function. For example, what we want here, we want to get the result, and we give it to the result from the function. So we want to add these two numbers using the addition function, and that result, we are calling it result. So it's what we want to hold. You can call it sum. So we want to hold the sum as the result of this function. Okay, and now we want to print. We print to the line, new line, and the result, we know now string literals and formatting, result. Yes, the next thing is to run. Let's run our code. Okay, by calling the Rust compiler, Rust C, main.rs. And when you're getting an error, not found, we're not using the result. I don't know why I'm using result. So we call it sum. I'll clear this console or the terminal, sorry. And then call the compiler again, Rust C, main.rs. And it runs, and I need to run the binary created main, and the result is 20, and that's what we expected. 17 plus 3, that should be 20. So that's a complete function. Okay, and instead of putting things here, that helps us to take things away, and this is some level of abstraction that we have hidden the addition from the main function, and what you need to do is to just provide the two arguments and call the function, and you get the result. Let's make it more interesting. We can declare a function and call it increase by, and this will take a mutable variable which is a U32, and how much, a variable called how much, and this is a U32 also. So we declare the types of these arguments that we are passing, and what we want to do is to increase this value by what? By how much? How much is what we want to add to this value. So in order to add, there are two options. You can do this, the value plus the new value will equal to the old value, whatever you will have, plus how much. Okay, but usually this is not a nice way. Well, programmers have ways of doing things. There is a better way of representing what we've written here, and you will, when you start looking at people's code, you will meet this value is plus equals to how much. That's more nice, short, and readable. Mathematicians might kill you when you do this, but this is the same as that. Okay, we can even add a print statement, print ln, and say you made string liters points val. So we want to print the new value because that is the new value after we add how much. So you made the val points, whatever it will be. So we can come to the main function and we declare a new value or variable, sorry, which you want to call score, and score will equal to 20 or 8. You can declare any value you want. So we call the increase by function. That means we want to add something on the score. So we want to add score as one of the argument, and then we want to add 30 to that value. I think we all know the result by now. Just add 30 on this. So when we run, call the Rust and then call main again. You made 278 points, and I think we all expected that. So this is the basic view of functions, and you can see what we're doing is functions are helping us write things, and then it alleviates pressure onto our main function. In a way, that's a basic entry into abstraction. So it is taking responsibility of certain things that we less worry about. So we are going to be looking at functions, of course, more of it, and use them more in our subsequent videos. In our next video, we are going to look at closures, and we see how those ones can be used. So that's it for today, guys. In this video, please leave a like or a comment, and don't forget to subscribe to the channel. Bye bye.